Welcome to our notes on vectors and a coordinate plane. Students will be able to graph a vector as a directed line segment and its standard position, calculate the magnitude and the direction of the vector. Read and mark up the following information about vectors. Use your markup to answer the guided text questions on the next page. I'm going to do minimal markup here, and by markup I mean, you write information in the margins if you need to, or in the blank spaces. You highlight things. Things like vocabulary is very important. Questions that you might have, all of those things. So I'm going to minimally mark up, but I expect you to do a lot more. A vector is an object that shows both magnitude and direction. Representing vectors geometrically with a directed line segment. You're going to have your initial point going to a terminal point. And we usually put an arrow from the initial point to the terminal point. Vectors are often denoted by bold-faced letters such as V, U, or W, or when we write it, okay, so whenever I write vectors, I'm always going to put a little half arrow on top. But on paper, when I print something out, the vectors will often be bold. The magnitude of the vector V is the length of the vector. We can denote the magnitude as the following. Either with a single bar like absolute value symbols or with a double bar. The direction of the vector V is the angle theta from a horizontal line to the vector V. Two vectors are equal if they have the same direction and the same magnitude. This means that if we take a vector and translate it to a new position, then the vector we obtain at the end of this process is the same vector we had in the beginning. Remember, translate means move left, right, up, or down. No rotations, no reflections. There are two different ways of representing a vector. First, we can represent it as a directed line segment, where we have an initial point P and a terminal point Q. And then we have the standard position, in which we translate the directed line segment and make it so that the initial point P is the origin 0, 0. You can change a directed line segment into standard position, keeping the magnitude and directions the same, by writing a vector in component form. So I'm actually going to underline that because that's another vocabulary word we must know. Where the initial point is P1, P2, and the terminal point is Q1, Q2. Then what you do is you subtract those components, the x components and the y components. So you get Q1 minus P1 for your x component, and Q2 minus P2. That's going to become your V1, V2, and that is going to be your vector. I put the little half arrow up here to make it very clear that that is a vector. And also, I know this looks like ordered pairs. Remember, ordered pairs look like this, x, y. Ordered pairs. But a vector actually have these symbols. So be careful. That x that I wrote in the vector is kind of like the x distance from the initial point to the terminal point. And the y is the y distance from the initial point to the terminal point. So that was a lot of vocabulary on the first page. Now let's try to synthesize that information. It says, answer the questions below about the reading on the first page. Number 1, you're going to do this problem. What is the difference between a directed line segment and a vector in standard position? Be ready to share this out in class. Number 2, part A. Find the component form and magnitude of the vector V that has initial point P, 5, 2, and terminal point Q, negative 2, 6. Show work in the space provided. So I'm going to follow the formula that was at the bottom of page 1. It's my little half arrow. Let me make that a little bit better. Okay, remember a little symbol like that. What I'm going to do is I'm going to take the terminal point and I'm going to just look at the x component of the terminal point, which is negative 2. And then I'm going to subtract the x component of my initial point, which is 5. Now I'm going to take the y component of my terminal point, and I'm going to subtract the y component of my initial point. And then I'm going to simplify. Negative 2 minus 5 is negative 7. and 6 minus 2 is 4. So here's my vector in component form, and when I draw this vector, I'm going to be drawing the standard position of that vector. 2b, graph the directed line segment of vector v and the component form of vector v on the same coordinate plane. So I'm going to graph the directed line segment as well as the standard form of the same vector. So first, I'm going to plot 5, 2. That was my initial point in my directed line segment. And then my terminal point was negative 2, 6. So that's P, that's Q. Use a ruler to draw a line from the initial point to the terminal point. And that is my vector as a directed line segment. Now to graph the component form of the vector v, what I'm going to do is I'm going to start my initial point at 0, 0. Remember, in component form, I'm really graphing the standard form of the vector. And then I'm going to graph negative 7, 4. Negative 7, 4. And again, use a ruler to draw a line from the origin to your vector. Now notice that vector v in component form and PQ is the exact same length, same slope, everything. Just think about it as a translation. If I took point P, which is my initial point, and I went down 2 units and then right 5 units into the same thing for Q, that's where I end up with my component form. So I can move this around by a translation up, down, left, right, and it will be the same vector. Number 3, how can you calculate the magnitude of a vector in the coordinate plane? Once you figure that out, go ahead and calculate the magnitude. And number 4, how can you calculate the direction of a vector in the coordinate plane? Then go ahead and calculate the direction of the vector that we drew in part 2.